Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay and safe. Today's topic of discussion is going to be derivatives of E. What is E? Okay, a lot of people, it's an exponent E, and it's called Euler's number, and it is 2.71828, and it goes up to infinity. There's no stopping, okay? So can you take a derivative or even integral of this number? Of this E, which is Euler's rule, Euler's number actually. And there was a scientist or a mathematician rather, his name was Jacob Leonard, I think. And in 17th century, he came up with this number right here called Euler's number. So I think it's important that I talk about what Euler's number is before we dive into derivative and integral of E, because it's important. I'm not really sure if I recall when I was in my class learning calculus, my professor just started taking integrals and derivatives of E, never really explained the background, how the E, this number, came into existence. So I studied it, so I would like to share that with you, okay? So what happened is that this mathematician Jacob Leonard in 17th century was chasing what is compound interest, okay? So let's see what his approach was, what his philosophy was, and see if I can make some sense out of that. So basically, like I said, he was chasing compound interest, okay? Compound interest is basically interest which is accumulated over a certain period. It could be a yearly, it could be a monthly, it could be every 6 months, and so forth. So let's say you go to a bank and the bank is real generous and they say, oh yeah, we'll give you 100% interest yearly, okay? So then you deposit $1 in the bank, okay? After 12 months, after 1 year, let's say 1 year, how much will this become? Obviously, everybody knows it's going to become $2, okay? Now, if I say, okay, can you give me interest rate every 6 months instead of 1 year? So what would happen then? What would happen then is that this $1 after 6 months will become how much? $1.50, right? Makes sense, right? So then I say, okay, well, you know, can you do this monthly? Can you give me monthly, interest monthly? So how would you calculate that? If you do it monthly, every month you're getting interest. So I would say 12 months, actually, sorry, 1 month, okay? This will become, if I'm doing it every month, then my, after 1 year, I will get $2.61, okay? So you see the pattern over here. If I do it, if the interest is compounded over a period of 1 year, I get $2. If the interest is compounded over 6 months, I get $1.50. And then after, you know, it's compounded again. If I do it every month, at the end of the year, I have $2.61. But compare this with the first one, all right? So then we say, okay, you know, how about can you compound this interest weekly? Of course we can do that. So then if you look at it, Jacob Leonard came up with a formula. And that formula, my friends, is 1 plus 1 over n raised to the power n, where this right here is the interest rate, okay? And this n is also the frequency. N is the frequency, or I should say period, monthly, yearly, weekly, and so forth. So now he came up with this formula, and then we say, okay, how about if you do the compound interest, if you do give me the interest weekly, how many weeks in 1 year? 52. So then I would have $1, which is my original amount, into 1 plus 1 over 52 raised to the power 52. This will give me, I calculated it for you guys, and this will give me $2.69 at the end of year, okay? So now I'm getting a little greedy over here. So I said, no, give me interest every day. All right. So then I have $1, my original amount, multiplied by 1 plus 1 over 365. All right. The whole raised to the power 365. So that, if you do calculation, this gives you $2.71 at end of the year. So you see, my friends, this pattern right here. This pattern right here is that if you increase the frequency of the time period where you're getting interest, okay, that's called compound interest, you will get more money at the end of the year. Same thing, watch out when you go to and apply for a credit card. Make sure that, they are not compounding your interest monthly or anything like that. It should be yearly. If you see, in the statement or disclosure somewhere that, hey, we basically accumulate interest which they are charging you monthly, that is not a good credit card then. It should be yearly. But anyways, coming back to the original solution. So this is the formula he came up with. 1 plus 1 over n, okay, raised to the power of 1, n, and whereas n goes to infinity, okay. So he kept on calculating this number, and then he finally came up that this is the number which is basically sort of like an average, okay. So this is called Euler's number, and what we're going to do in our next lesson is we're going to see if we can take a derivative of that. We're going to take integral of that and see how that comes out. So stay tuned. I will be back and we'll have some more fun. Thank you so much for watching. If you like the contents, please go ahead and give me a like. Thank you.